Let us continue our discussion about theorem. So let's start with theorem number 6. Form A, AB plus AB naught is equal to A. Form B, A plus B added to A plus B naught equal to A. So when to use theorem number 6? If we are dealing with two terms, and these two terms have the same number of variables, like on the first form, we have two variables, and we have a common variables or common variable. So we have common variable A, and last, we should have a complemented variables B and B naught. So when we have this, therefore, the result will be, or the simplified version of the equation is equivalent to common variable, which is A. Okay, so let's have an example. ABC plus AB naught C. So let's check if it follow this criteria. Two terms? Yes. Equal number of variable? Yes. Must have common variable? Yes. A and C. Must have complemented variables? B, B not. Therefore, theorem number 6 could be implemented. So let A equivalent to AC, B equal to B. Substitute. We have AB plus AB not. Form A. Therefore, it is equivalent to A, which is AC. So this is our final answer. Another example. Let's have these four terms. So can we implement theorem number 6? Definitely yes. So we have W naught plus X naught plus Y naught plus Z naught added to W naught plus X naught plus Y naught plus Z added to W naught plus X naught plus Y plus Z naught added to W naught plus X naught plus Y plus Z. So for the first two terms, okay, can we implement theorem number 6? Possible, yes. So do we have common variables? Number of terms first. Yes, four. Common variables, yes. W naught, X naught, Y naught. Do we have complemented variables? Z naught and Z. So therefore, we could implement theorem number 6 for the first two terms. So let A, W naught plus X naught plus Y naught B is equal to Z. Substitute. We have A plus B added to A plus B naught, second form. And then the result will be just A. So we have W naught plus X naught plus Y naught. Okay? And for the last two terms, do we have common variable? Yes. W naught, X naught, and Y. And do we have complemented variables? Yes, Z naught and Z. Do we have same same number of variables? Yes, four. Therefore, theorem number 6 could be implemented. So let A, W naught plus X naught plus Y, and B is equal to Z. So using second form, we have A plus B added to A plus B naught. Therefore, it's equivalent to A. Basically, it is equivalent to W naught plus X naught plus Y. So we have these two equations when we combine the first two and the last two. Can we simplify this further? Probably yes. So let's check. Do we have common variables between the two? Yes. W naught, X naught. Do we have complemented variables? Yes. Y naught plus Y naught and Y. Therefore, theorem number 6 could be implemented. So let A, W naught plus say X naught, B is equal to Y. Using the second form, we have this equation. Therefore, it is equivalent to A, which is equivalent to W naught plus X naught. So this is the simplified version of the four terms, four variables. Okay? So now let's move on with proving of theorem number 6. So we have AB plus AB naught. Is it really equal to A? Okay. So do we have a common variable? Yes. Factor it out using distributive law. We have A added to B plus B naught. And we all know that anything or to its negation or to its complement, it's equivalent to 1 based on postulate 6. Anything added to 1 based on postulate 2 is the same as the original variable, which is a. Okay? And comparing it all of the right side of the equation, they are the same. So therefore, form A is correct. How about form 2? So we could implement distributive law. So since we have a common variable here, which is A, so we're just going to have common term A plus the other variables under and operation. So we have A plus BB naught using distributive law. And we all know that BB naught based on postulate number 6, it's equivalent to 0. And anything or to 0 is equivalent to itself based on P2. So therefore, it's equivalent to A, which is the same as the right side of our equation. Okay, theorem number 7. AB plus AB naught C is equal to AB plus AC. Second form, A plus B added to A plus B naught plus C is equivalent to A plus B added to AC. Theorem number 7 is basically an extension of theorem number 6. It's almost the same. The only difference is they are not equal. The given terms are not equal in size. Okay, so how do we determine if theorem 7 could be implemented in simplifying our equation? So first, we are dealing with two terms. Second, not equal size. We have two variable, three variables, and must have a common variable, which is A. And there's a complemented variable, B, B naught. If we have this criteria, therefore theorem number 7 could be implemented. So let's have an example. Wy naught plus Wx naught y plus Wxyz plus Wxz naught. Okay, so let's start with the first two terms. Let A is equal to W, B is equal to Y. Okay, so substitute, we have this equation. AB naught plus ABX naught. Is it the same with the first form? Yes. They are not equal in size. They have common variable, which is A. They have complemented variable, B naught and B. So therefore, theorem number 7, we have AB plus AC, wherein C is X naught. So we have AB plus AX naught. Then we have Wy naught plus Wx naught for the first two terms. Okay, now second and third. So let A is W, B is equal to X. Okay, so substitute for the second and third term. So we have AB naught plus AB YZ. Again, is it the same as form A? Yes. YZ is equivalent to C. Therefore, we have AB plus AC or AB naught plus AYZ. Okay, so the equation will be Wx naught plus Wyz. Okay, so now we have this equation. Wy naught plus Wx naught plus Wyz plus Wxz naught. Okay, so second and fourth now. So let A is equal to W, B is equal to X. So we have Wx naught plus Wxz naught. Substitute, we have AB naught plus ABZ naught. Is it the same as form A? Yes. So we could remove B on the bigger group. So we have AB naught plus AZ naught, or basically we have W. Okay, here it should be W X naught plus wz. Okay, so that will be our answer. And then can we simplify it further? Probably yes. So factor out w using distributive law. And by inspecting the second term, can we simplify it further? Yes, because we have z plus z naught. We all know that anything or to its negation is equivalent to 1, again based on P6. And analyzing the second term, we have OR to 1. Based on theorem number 2, anything OR to 1 is equivalent to 1. And anything AND to 1 based on P2 is equivalent to itself. So therefore, from 4 terms, it equals to one variable, which is W. Okay? Another example. We have x naught y naught plus z, and then to w plus x naught y naught plus z naught. We have two terms, not equal size, yes. Must have common variable, which is x naught y naught, complemented variable z and z naught. So let A, x naught y naught, let B is equal to z, and w is equal to c. Okay, substitute. So we have a plus b and the two w plus a plus b naught. Definitely, this is the same as letter B, form B. Okay, so therefore, we could eliminate the complemented version of B in the bigger term, or has more variables. So B naught will be removed. So we have a plus b and the two w plus a. Therefore, we have x naught y naught plus z and then to w plus x naught y naught. So this will be our answer. Okay, to prove that theorem number 7 is really correct, okay, so let's manipulate form A first. So let's factor out A. So we have b plus b naught c. And using theorem number 5, we could remove b naught. So we have b plus c. And using distributive law, we have AB plus AC. So therefore, theorem number 7 is correct for form A. Form B, using distributive law, we have this equation. Using distributive law, we have this equation. And we all know that BB naught is equal to 0 based on P6. And we all know that anything or to 0 is equivalent to itself. And using distributive law, we could separate BC, okay, and A will be common between the terms. So we have A plus B plus added to A plus C, which is the same as the right side of form B theorem number 7. Okay, so let's continue our discussion on the next video lecture. Thank you for listening.